Hello students, in this video we are going to study about connected bodies, those are in motion. So we have multiple bodies present and they are in contact, they are connected. Now the connection can be like they are directly in contact or they are connected via some rope, and the system is in motion. So we have connected bodies that are in motion and we are going to study that type of system. Also, this topic is very important as per the class 11th examination or any other entrance examination. In every exam we can see questions from this topic coming in the question paper, and there are many variations in questions. There are various type of questions in this category. So we will start with the very basic questions and theory and we'll move to the difficult ones. So this lecture will be in two parts. Part 1 is the basic one and part 2 जिसमें हम थोड़े डिफिकल्ट क्वेश्चंस के साथ डील करेंगे जो आपको तभी बेटर समझ में आएंगे इफ़ यू हैव सीन पार्ट 1. So let's start with the part 1 of this video. We are going to study with connected bodies. So for that we have to consider at least two bodies. So I am going to consider two bodies. Body 1 with mass capital M and body 2 with mass small m, and as we can see by capital M and small m I mean that capital M is greater than small m. So जो मेरा heavier object है that has mass capital M and the lighter one has mass small m, and these objects are connected to each other by using a string and a pulley. So here I am drawing the diagram for the system that this is the mass capital M, and by this string and a pulley it is connected to the second mass that is small m, which is the lighter one. So when these two masses are connected in this way, then the heavier mass will go downwards because of the gravity and its weight. ये नीचे आएगा and जितने acceleration से this will move downwards, from the same acceleration the lighter mass that is a small m will go upwards. So I am assuming that small a be the acceleration with which capital M moves downward, then this will be the same acceleration जिससे ये small m ऊपर जाएगा. So this is capital M moves downward and small m moves upwards. This is the situation. Since masses are connected to a string, so ये जो point of contact होंगे यहाँ पर एक tension setup होगा, and the rope or the string that we are using, that is massless. We are considering that this string is massless. Then in case of stringless, massless string or rope, tension at every point remains same. तो हमें दो चीज़ें याद रखनी है. फर्स्ट, अगर आपका रोप मासलेस आपने कंसीडर किया है और ऑफ निग्लिजिबल मास कंसीडर किया है, देन इन दैट केस tension at every point of that rope will remain same. First thing. Second thing, tension always act away from the point of contact. The direction of tension is such that it always act away from the point of contact. So from this point of contact it will act like this. This is away from the point of contact. Similarly for this it is also away from the point of contact, and this tension will be same because the string or the rope that we have considered is massless. Then at every point the tension will be same, and let it be capital T. Now the weight of these objects are acting downwards, that is capital Mg and small mg, and this capital Mg वाला जो object है, means capital M mass का जो object है, that is moving downwards, and this small m वाला जो lighter object है that is moving upwards. Since there is motion, that means यहाँ equilibrium का stage नहीं है. net force is not is equal to 0. So we are going to write equations for these force in for both the masses one by one. So हम दोनों masses पे लगने वाले forces के लिए equations लिखेंगे. So I am going first for this capital M mass. The net force that is acting on this mass capital M, it is ma. M is its mass and acceleration, force is equal to ma, and it is going downwards. So the net force that is acting on it is capital Ma, but it is the resultant that we get from these two forces. So T and mg are balancing each other such that the net force that we are getting is ma in downwards direction. Since it is in downwards direction, that means कि mg का value t से ज़्यादा है. That's why we are getting a downward motion. So for mass capital M, the equation will be mg minus t is equal to net force, and net force is equal to mass into acceleration downwards. It is downwards because this mg is downwards and mg is more than t, and that's why we are getting ma in downwards direction. This is for capital M. Similarly, we are going to write the equation for resultant upward force acting at the object of mass small m. Then for this, resultant is ma in upward direction. Since this is in upward direction, so that from that we can conclude कि ये जो tension T होगा, it will be more than mg. That's why we are getting resultant force in upward direction. So the difference we have here will be T minus small mg, or I should write it like T minus mg is equal to ma. ऐसे भी लिख सकते हैं हम, बट आई एम राइटिंग इन दिस फॉर्मेट बिकॉज इक्वेशन नंबर 1 में भी मैंने इसी फॉर्मेट का यूज़ किया है. नाउ व्हेन वी गेट इक्वेशन नंबर 1 and 2, the simplest method to find acceleration is by eliminating t, and to eliminate t just add equation 1 and 2. So we are going to add equation number 1 and 2 to find the acceleration. Then we get, if we add these two equations, we get mg minus t plus t minus small mg. It will be ma plus small ma, and if you solve this, t and t will be cancelled out and we get m minus small m and g common is equal to m plus m a common. So our target was to find acceleration, and we get acceleration is equal to m minus m plus m into g. So this is the value for acceleration from which the particles are moving downwards and upwards. Now once we find acceleration, we can find tension also by substituting this value in either equation number 2 or in equation number 1. So by putting the value of a in any of the equation, we can find the value of t. I am substituting it in equation number 2. So t will be ma plus mg, and when we substitute the value of a, it will be m common, and a की जगह पर वैल्यू आ जाएगा m minus m plus m g plus g. Okay, now g can also be common, so ये हो जाएगा m g, and within the bracket it will be m minus m. Now it's on you कि आप उसको कितना सॉल्व करना चाहते हैं. So that's how we can find tension also. T is equal to mg, m minus m plus capital M plus small m, and upon में capital M plus small m. These m will cancel out and we get twice of capital M, mg upon m plus capital M plus small m. So this is the answer for the tension that is producing in the string because of the connected bodies. So basically the concept is write the equations for force, add those equations to find acceleration or to eliminate t, and then substitute that value in any of the equation to find the tension, and rest we will discuss according to the question कि कैसे आपके क्वेश्चन में क्या निकालना है and हम कैसे उसको वर्कआउट कर सकते हैं. So let's move to the questions for this topic. So question number 1 states that there is a pull of 15 Newton applied to a rope attached to a block. So we have a block of mass 7 kilogram and a rope is attached to it, on which a pull of 15 Newton is applied, means in this direction it is pulling, and this block is lying on a smooth horizontal surface. So the meaning of a smooth horizontal surface is the surface is frictionless. We are not going to consider any forces because of the friction, and the mass of rope is 0.5 kilograms. So rope is not massless, it has mass 0.5 kilogram. We have to find the force exerted by the block on the rope. So we want to know the force that is exerted by the block on the rope. This is the pull that we are applying on the system of block and rope, and at this point of contact this block is applying some force on the rope. Let this force be T, and this rope, according to the Newton's third law, is also applying an equal and opposite force to this block. Let that force be T dash. This will be in this direction. The rope is applying this force T dash on the block, and according to Newton's third law of motion, T dash is equal to T, where T is the force that is applied by block on the rope and T dash is the force that is applied by the rope on the block, and we have to find the force exerted by the block on the rope. That means we have to find T. This is our task. We have to find T, but according to Newton's third law of motion, T and T dash are equal. Now come to this force. We are pulling the system, this whole system, by a force of 15 Newton. So this force of 15 Newton is actually equal to the net force applying on this system. So net force on this system is the mass into acceleration. Let the acceleration by which the system is moving towards right is A. Then mass of the system is 7 for the block and 0.5 for the rope into A. This much Newton is the net force, which is equal to 15 Newton. So by solving this we can get the acceleration by which this whole system is moving towards the right. So let's solve it for acceleration. Then we get 15 is equal to 7.5 A, and that implies A is equal to 15 upon 7.5, or it is 2 meter per second square. So the acceleration with which this block is moving because of that pull of 15 Newton is 2 meter per second square. Now this much is the acceleration we know. That means the net force acting on this block. So we have to find the force exerted by the block on the rope. That means we want to find T, and this T is actually equal to T dash, which is the force exerted by the rope on the block. So we are calculating T dash, and T will be equal to T dash. So T dash is the force acting on block because of rope. Now this force is equal to mass into acceleration. Mass means mass of block only, and the acceleration, so mass of block is 7 and acceleration is 2 meter per second square, that we have calculated. So this T equals to T dash is equal to 14 Newton, and that is the required answer. 14 Newton is the force exerted by rope on the block, and it is equal to the force exerted by block on the rope. So force exerted by block on rope is equal to T, that is equal to T dash, and is equal to 14 Newton. That is the required answer. Now let's move to the question number 2. Here question number 2 states that there is a wooden block of mass 2 kilogram rest on a soft horizontal floor, right? So we have a block of 2 kilogram resting on a horizontal floor, and an iron cylinder of mass 25 kilogram which is placed on the top of the block. Then the floor yields steadily, and the block and cylinder together, means the system of the two together, go down with an acceleration of 0.1 meter per second square. then we have to find the action of the block on the floor. Action of the block means basically the force that block is applying on the floor before and after the floor yields. Means before placing the cylinder and after placing the cylinder, we have to find the action of block on the floor. First I am talking about the case when case 1 means before yielding. So for that we have a wooden block of 2 kilogram. This is a wooden block of 2 kilogram resting on a horizontal floor, and in this case the forces acting on this block are, first is its weight, that means 2 into 10, that is equal to 20 Newton, and the second one is the reaction, normal reaction acting on it, let it be R. Now the first force that is acting on this block is its weight, that is equal to mg, or 2 into 10, because it is given that we have to take g is equal to 10, that means 20 Newton. And the second one is the normal reaction, and since there is no motion happening in this block, that means these forces are balanced and the normal reaction is equal, has a value equal to the weight 20 Newton. So R is equal to mg, and that is equal to 20 Newton. Now we have to find the action of block on the floor. So block की वजह से फ्लोर पे क्या एक्शन हो रहा है, वो ये वाला फोर्स है, मीन्स द फोर्स दैट इज एक्टिंग बाय द ब्लॉक ऑन द फ्लोर, ब्लॉक जितना फोर्स लगा रहा है फ्लोर पर, दैट इज द एक्शन ऑफ ब्लॉक ऑन द फ्लोर. सो in before case when there was no cylinder, in before case action of block on the floor is equal to a force of 20 Newton vertically downward, because it is in the direction of its weight. So vertically downward, this is the case 1. Now for case 2, we have put a cylinder of 25 kilogram over this block. So this is the situation, we have a 2 kilogram block and over it we placed a cylinder which has a mass of 25 kgs, and then this whole system starts moving downward by an acceleration of 0.1 meter per second square. So suppose their new position is here, they yield this much and the acceleration for this motion is 0.1 meter per second square. So they will slide to this position like this. In this case, the forces acting on the system are the weight of the system, means this time we have mg, which is equal to mass is the sum of the masses of both cylinder and block, that means 25 plus 2g, or we can write it as 27g, that means 270 Newton, because g is equal to 10, and there is a normal reaction R dash, but this system is moving downwards, that means these two forces are not balancing each other, there is some acceleration, so we have to find the net force. Now the motion is towards downwards, that means this downward force is greater than the normal reaction. So first force that is acting is its weight of the system, which is 25 plus 2 g, or 270 Newton, this is vertically downwards. Second force that is acting is R dash, which is the normal reaction, and since there is a motion in the system, that means these two are not balanced, so we can't write R dash is equal to 270 Newton, these are not equal. We have to find the equation, we have to write the equation of forces for this system. Since the motion is downwards, this shows that 270 Newton is more than R dash. So our net force is 270 minus R dash, which should be equal to mass into acceleration. So mass is again 25 plus 2 and acceleration is 0.1. By solving this, we can get the reaction, normal reaction R dash, which is equal to 270 minus 27 into 0.1, and on solving we get R dash is equal to 270 minus 2.7, and this is equal to 269 267.3 newtons. So this is R dash. Normal reaction is 267.3 newton. This is vertically upwards, and by using Newton's third law of action and reaction, since we know that from third law of motion the action is equal and opposite to the reaction, so the reaction, normal reaction R dash, is 267.3 newton vertically upwards. So the action we want to find for the floor is 267.3 newton vertically downwards. So the action of the block on the floor is 267.3 newton vertically downwards. In this case, in the second case, this is not only because of the block, this is because of the whole system, because now the block and the cylinder are acting as a system. So this action is because of the system, and we are using third law of motion to calculate this. After this, we will move to question number 3, in which we have 3 masses. So here in question number 3, we have 3 blocks M1, M2, M3. Their masses are given 5, 10 and 15 kgs respectively. A force is acting on third mass, it is of 50 newton towards the right. So we are pulling the system from the third block towards right by a force of 50 newton. This is shown in the diagram, and the whole setup is lie on a smooth table. That means there is no friction. The surface is frictionless. We are not going to consider any friction force, and we have to find the tension T1 and T2 in the strings. Now T1 and T2 are here. This is T1 and here the tension is T2. This is given in the diagram, and we have to find the tension T1 and T2. For this, again we consider these blocks separately one by one and write equations for them. So let's start with the first one. If we see this one, the mass M1, the net force acting on this mass M1 is actually T1, and it has an acceleration A, its mass is M1. So we can write for the object, for mass M1, we have net force is equal to M1A, and this net force is equal to T1 because the only force acting on it is T1. That means T1 is equal to M1A. This is equation number 1. Similarly, we are going to write the equation for T2, means for object 2. So for mass 2, now this is not only for mass 2, because T2, when we are trying to find T2 or writing equation for T2, this is applied to both. This pull that we are pulling from this section, and this pull is applied to both M2 and M1. So in this case, we have to consider the whole system of M1 and M2. That means the net force for this T2 के लिए अगर हमें लिखना है, then we have to consider this whole system. Net force will be M1 plus M2A, and on left hand side in terms of tension it will be T2, because इस पूरे system पर जो pull यहाँ से हम लगा रहे हैं that is T2. So T2 is equal to M1 plus M2A. Now for mass M3, means for this section, अगर हम इस वाले section की बात कर रहे हैं, for this section we have net force is equal to M1 plus M2 plus M3A. This was equation number 2. And in this section, अगर हम यहाँ से pull कर रहे हैं, then the net force acting on it is capital F. So this force is capital F, which is equal to M1 plus M2 plus M3A. This is equation number 3. Now we can find all the values by using equation 1, 2 and 3 one by one. So I am starting with equation number 3. From equation number 3, we know the value of F, M1, M2, M3 and can get A. So A is equal to F upon M1 plus M2 plus M3, which is equal to 50 upon 5 plus 10 plus 15. That means 50 upon 30, or the acceleration is 5 upon 3 meter per second square. This is the acceleration. Now we can find T2 by putting the value of acceleration in equation number 2. We get T2 is equal to M1 plus M2A. So this will be m1 plus m2 into 5 by 3, or 5 by 3 into mass 1 and mass 2 was of 5 and 10. So this is 15, 3 5s are 15, and 5 into 5 is 25 newtons. So T2 is 25 Newton. Now we can find T1 also by the same method. For T1 we are going to substitute the value of acceleration in equation number 1. So T1 is equal to m1a. T1 is equal to m1a, mass 1 is of 5 and acceleration is 5 by 3. So the value become 25 by 3 Newton. These are the required answer for acceleration T1 and T2. In question it was asked to find T1 and T2. So these are the required tensions in the string or the rope that we are using. That's how we have to solve this problem. Now moving to question number 4th. Question number 4th is somewhat similar to the question number 3rd. So let's see, there are 3 masses again. Now this time the values are m, 3m and 5m and connected together and placed on a frictionless horizontal surface. In the previous example we were pulling them towards right. This time we are pulling them towards left by a force capital F. This time the force is not given. In the last question it was given. Now the value is capital F, and the tension in the string, in the first string, that is T1, this is given. We know T1 is equal to 24 newtons, and we have to find T2, that is the tension in second string, and the force capital F. So first of all we write equations just as we write in the previous question, and then we'll solve the equations for the required values. Let's start. So for first object, means I am moving from left to right. We are considering it from left to right. If I want to write equation for the tension T1, then this T1 tension is applied to the system of 3m and 5m, right? So net force is equal to mass into acceleration, that means 3m plus 5m into a, if I am assuming that a is the acceleration by which this system is moving towards left. So T1 is applied to the system of 3m and 5m block. That means if the net force is T1, then its value will be 3m plus 5m into a, and by solving this I can find the value of a, because I know that T1 is equal to 24. So a is equal to 24 upon 8m. That means the acceleration is equal to 3 by m. So we get the acceleration. Now we have to find the tension in second string, that means T2. So tension in second string is equal to, this tension is applied to this block only, means mass into acceleration जब हम लिखेंगे then it will be 5m into a, and we know the value of a, that is 3 upon m. So 5m into 3 upon m. On solving we get T2 is equal to 15 Newton. This is the answer for T2. We also have to find the force capital F here. For capital F we have to write the equation for the whole system. Then for capital F we get F is equal to mass into acceleration, and this F is applied to all the 3 masses, means m plus 3m plus 5m into a. So for this capital F is equal to m plus 3m plus 5m, means all the 3 blocks into a, that means 5 3 8 and 1 9m, and acceleration is 3 upon m. So the answer for force is 27 Newton. This is the required answer for force and tension in the second string. After this let's move to the next question, question number 5. It states that we have 3 masses as shown in the diagram, m1, m2 and m3, and their values are also given, 5, 2 and 3 kilograms respectively. They are connected as shown in the diagram, and the value of tensions in each section is T1, T2 and T3. Now we have to find when the whole system is going upward with the acceleration of 2 meter per second square, means if the whole system is going upward with an acceleration of 2 meter per second square, in that case we have to find the values of T1, T2 and T3 for the first part. And for the second part, if the whole system is stationary, then we again have to find T1, T2 and T3. So we will try to write equations by taking acceleration a, like in general. For case 1 we put a is equal to 2, and for case 2, for second part of this question, since it is saying that the system is stationary, we put a is equal to 0. So equations will be same in both the parts, but value of acceleration will change. For first part it is 2, and for stationary case it will be 0. So first of all we will write force equations for all the 3 blocks, or I should say for all the 3 point of contacts. So here I have write equation for this point of contact. Now see how I am writing this. We know that the net force acting is equal to mass into acceleration. So the net force should be the total mass into acceleration by which the whole system is going upwards. So it will be m1 plus m2 plus m3 into a. This is the net force. But as per the diagram, this net force should be equal to the difference of the tension that is acting upwards and the weight of the system that is acting downward. So for this point of contact, the weight is acting downward, and that weight will be equal to the mass of all the 3 blocks into g, means m1 plus m2 plus m3 into g is acting downwards, and tension at this point is acting upwards, but the net motion is towards upwards, that is given in question. That means T1 is greater than the total weight. That's why we are writing T1 minus the weight of the system is equal to this. This is for first point of contact. Now for second point of contact, means for this point of contact, the tension T2 is acting upwards, weight acting downwards is m2 plus m3 into g. In दोनों का weight is acting downwards, and the motion of the system is towards upwards, which shows that this tension T2 is more than the weight that is acting downwards. So for writing the equation for this point of contact, T2 is more than the weight that acting downward. So T2 minus m2 plus m3 g, and this is equal to the net force, means mass into acceleration. So it will be m2 plus m3 a. This is equation number 1. This is equation number 2. Similarly, for third point of contact, we can write T3 minus m3g is equal to m3a. Now this is because m3g is the weight of this block that is acting downwards, T3 is acting upwards. So the net force is equal to the difference of these two. But the motion is towards upwards, which shows that the upward force T3 is more than m3g, and we have to take the difference T3 minus m3g. This is equation number 3. Now for case 1 of this question, we will put acceleration is equal to 2, and for second case we will put acceleration is equal to 0. So for case 1 I am going to put acceleration is equal to 2 and we'll solve these equations one by one. So we get T1 is equal to m1 plus m2 plus m3. This is common in both the terms if this term comes to the right side, and within the bracket we will get a plus g. Now m1 plus m2 plus m3 is 5 plus 2 plus 3, that means it is 10. 5 and 2 7 and 3 10, and a plus g is 2 plus 9.8, so it will be 11.8, and the answer that we get for T1 is 118 Newton, right? This is for T1. Now for T2, we have m2 plus m3 into a plus g. Again m2 plus m3 is 2 plus 3, that is 5, and a plus g is 2 plus 9.8, that means 11.8, and the answer for it will be 59 newtons. If you solve this, you get 59 newtons. Now for T3, it is equal to m3 a plus g, that means 3 into 11.8, and the value for this will be 35.4 newtons. So these are the answers when the system is moving upwards by an acceleration of 2 meter per second square. Now for case second, we will put a is equal to 0 in all these equations. Then in that case we get T1 is equal to m1 plus m2 plus m3 a plus g, but a is equal to 0, that means it will be 10 into 9.8 or is equal to 98 newtons. right? Acceleration A will be 0 for stationary system. Similarly, T2 is equal to m2 plus m3 A plus g. Acceleration is equal to 0, that means it will be 5 into 9.8 and the answer will be 49 Newton. And for T3 it is m3 A plus g. A is equal to 0, so it will be m3g, that means 3 into 9.8 and answer will be 29.4 Newton. So this is the required answer for the second case. These are the answers for stationary case, and these are the answers when object is moving, the system is moving actually with an acceleration of 2 meter per second square. So that's it for the part 1 of the video. Further questions we will continue to part 2 of this video, so stay tuned for that.